In this video, we're going to look at the Robinson annulation. Let's jump right in. There are two reactions in the Robinson annulation. One is a Michael addition, and two, there's an Aldol reaction, an Aldol condensation, in order to make the ring. So let's look at an example. So let's take cyclohexanone and this conjugated ketone, and we'll do a Michael addition to start with. So if I add a base, like hydroxide or something, on the cyclohexanone, we'll see that there are alpha carbons next door to the carbonyl, and I can deprotonate one of those protons to make that stable enolate. And then I'll draw my conjugated ketone. And we know in a Michael addition, we get 1,4 addition or conjugate addition. So that enolate attacks that carbon. The electrons go up. To make that, the electrons come back down and they grab a proton off of my solvent, often an alcohol. And we would make this compound. We could jump there a little faster when we realize that this carbon attacks that one. That double bond just becomes a single bond, and I have this attached to that with a single bond right here. This is the Michael addition. The second step of the Robinson annulation is to do an Aldol condensation in order to make a ring. And now, if I add more base, there's more base in here, where are the hydrogens that I can pull off? Where are their alpha carbon hydrogens? Well, there are some here. This next to a carbonyl. There's one here next door to the carbonyl. No, not here. I guess there's some here, and there's some here on this methyl. Now, I could deprotonate several different places, but the one that is most interesting to me is if I deprotonate here. So I get a negative carbon where that methyl is. And the reason that one's interesting, I want to use a different color here, is it's going to backside attack that carbonyl for my aldol. And let's number the carbons here. 1, 2, 3, 4, 5, 6. So I'm going to make a 6-membered ring. So this was carbon 1, this is carbon 2, 3, 4, 5, and 6. So carbon 1 attacked carbon 6. The electrons went up onto the oxygen to make this compound. The reason this was the important carbon is it made a very stable 6-membered ring. If I deprotonated at carbon 3 and tried to make a ring, the ring would be too small. So any other spot, I ended up making, I couldn't make a very stable ring like I did by deprotonating that methyl, and it could backside attack that carbonyl to make a nice, stable 6-membered ring. So we finish up our aldol condensation. We can protonate with some acid. And we remember it can dehydrate by pulling off one of these hydrogens in the water. To make this conjugated ketone when I'm done. And that's the final product of my Robinson annulation. So the Michael followed by Aldol deprotonating, attacking the carbonyl to make a ring, the Robinson annulation. Hey, I hope that was helpful. Think about subscribing to the channel. so I can continue to help you with your organic chemistry.